This is a continuation of the Test 4 review questions. We're picking up with question number 4, which reads, Carl Icahn wants to make regular monthly deposits into his 401k in order to accumulate $4 million in 25 years. If Carl expects an annual interest rate of 8.5%, then what should Carl's regular monthly deposit be in order to achieve his $4 million goal? Okay, this particular problem requires a formula. The formulas are not provided on test 4, so you may definitely want to write this down, this particular formula, and have it handy when you're taking the test. And the first thing you want to do when you are looking at this problem is to identify the different pieces that you have and what you're looking for. So it says he wants to accumulate $4 million, which would be my accumulated or my ending value represented by A of T in 25 years. So that's my time in years is 25. He expects an annual interest rate of 8.5%. So my interest rate as a percentage is 8.5%. For calculation purposes, though, that particular percentage needs to be converted to a decimal. Now, remember, to convert to a decimal, you take the percentage of 8.5 and divide it by 100, which gives you 0.085. Continuing reading then, it says, what should his regular monthly, okay, so we're going to compound the interest monthly, and there are 12 months in a year, so N is 12. And in this scenario, we're looking for P, or what his monthly deposit would be. So once you've identified the information given in the problem and you have the formula, at that point it becomes a substitution or a plug and chug problem. So we would have 4 million equals some payment amount or deposit amount that we're looking for times 1 plus 0.085 divided by 12 raised to the 12 times 25 power minus 1 divided by 0.085 over 12. Okay, once you get it all plugged in, basically at that point you want to use your calculator and you're going to walk through the calculations as though you were doing it by hand, following order of operations. So working on the right hand side, following order of operations, we need to do the piece inside the parentheses first, okay, because we do parentheses first. So we would have 0.085 divided by 12. And then we want to add 1, continuing working within the parentheses. And then we need to raise that answer to the 12 times 25 power. Make sure to put that in parentheses. Get the answer. Subtract 1. Get the answer. And then we have to divide that by the expression in the denominator. We're going to put parentheses around it, 0.085 divide 12, and that equals. So once you've done all this calculation in that big old gloobly glop fraction, what we have is 4 million equals some payment amount times, and let's see what that number was, 1,032, okay, 1,032.05831. Then we're going to do the division, because remember we're trying to solve for P. So I'm going to divide both sides by 1,032.05831. Okay, so I have 4 million divided by 1,032.05831. And so I end up with 3,875.75, because we're talking about money. We use 2 decimal places. And so Carl should deposit $3,875.75 per month in order to end up with $4 million in his 401k in 25 years. All right, the next question asks you to represent the expression 4 log of x minus 2 minus 3 log of x squared minus 4 plus 2 log x plus 3 is a single logarithm. See, at the moment we have 3 logarithms, so we got to use the properties of logarithms to rewrite this so that you only have 1 log. And the first thing that jumps out at me in this problem is that you have these numbers in front of each log. And if I remember my rules right, basically that particular number out front should become the exponent. So if I rewrite it, I'm going to have log of x minus 2 to the 4th minus log of x squared minus 4 to the 3rd plus log of x plus 3 squared. Then we work left to right, just like you do anytime you're working with a multiplication problem. And so if we look at the first 2 pieces together, that's a subtraction problem. Subtraction translates back into division. So if I rewrite this, I would have log of x minus 2 to the 4th divided by x squared minus 4 to the 3rd. And I still have plus log x plus 3 squared. Continuing to work left to right, this is now 2 logs that are being added together. Addition translates to multiplication. So I have log of x minus 2 to the 4th over x squared minus 4 to the 3rd times x plus 3 squared. Technically that's over 1. So that when I simplify, I have log of x minus 2 to the 4th times x plus 3 squared over x squared minus 4 to the 3rd. Now from there, we do need to do a little bit of simplifying. So x squared minus 4 actually factors. So it can be rewritten as, we would have log of x minus 2 to the 4th times x plus 3 squared over, we would have x minus 2 to the 3rd times x plus 2 to the 3rd. Okay, x squared minus 4 factors is x minus 2, x plus 2, and the exponent applies to both. So then, if you notice, you have the same base of x minus 2 in the numerator and the denominator. There are 4 in the numerator, 3 in the denominator. You subtract the exponents. So these 3 in the denominator are going to divide out, and I would have 1 left in the numerator. So we end up with the log of x minus 2 times x plus 3 squared over x plus 2 to the 3rd. Okay, so you do want to always try to simplify your problem, okay, in the end. Anytime you have fractions, you always want to try to simplify. So there's your final answer. Question 6 is really just a plug and chug problem, guys. Don't let it kind of scare you there, okay? Because if you look at it, It says, after 2 years, the value of a car that originally cost $23,970 is given by, and it actually gives you the formula or the equation that you need here in the problem. And then it asks you, what is the value after 7 years? So it's telling you, we want to know what happens when t, or the years, is 7. So it's basically going to be a straight, flat-out substitution problem. We have $23,970, which is what we originally paid for the car, 3/4 raised to the 7th power. And guys, that becomes a calculator problem at that point. Okay, so you would simply type, and again, following order of operations, I would do the exponent first. So parentheses, 3, divide 4, close the parentheses, raise it to the 7th power. I get 0.1334838867, and I'm going to multiply that answer times 23,970. And so I end up with, after 7 years, the value of the car is $3,199.61. Again, we're dealing with money, and typically with money, you're going to round things to 2 decimal places.